Hey guys, it's Miss Carlson again, and today I'm going to talk to you about Chapter 14, which covers work, power, and machines. I'm going to hold off and just talk about work and power today and save machines for another time. Also, make sure you have a Cornell note-taking template or a blank sheet of paper to get you started. I will have a few practice problems for you in this set of notes, so you may also want to go ahead and grab a calculator and you will show me those in your notes that you did them and work them out. So don't forget to show your work, show your variables, circle your answer. And let's go ahead and get started. Work is when you apply a force to something and cause it to move, and it should move in the direction that the force is applied in order to be considered work. Now, if the motion of an object is not in the direction of the force, then no work is being done. There's no exceptions for that. In these pictures here, you have two guys. One's holding a weight over his head. This guy's holding another soldier on his back. As they stand right now, they are not doing any work. Nothing is moving. They're standing still. But the act of this man lifting that weight up was doing work. And the act of this man putting the other soldier on his back was doing work. But now as they stand, if they're not moving, they're not doing work, even if they still are holding something up. And I think that can get kind of confusing because I think when we feel like we're doing work when we're still holding up a weight or picking up a person. But if it's not moving, work isn't being done. In these three scenarios, who do you think is doing work? A teacher lecturing her class. B, a mouse pushing a piece of cheese with its nose. Or C, a book falling off a table and free falls to the ground. I'll give you a few seconds and you can pause so I don't give away the answer too soon. Hopefully you chose the mouse and the cheese and the book are all examples of work being done. But what force is acting on the book? Because it's pretty obvious the mouse is moving the piece of cheese, so it's doing work. The force that's acting on the book is what? Begins with a G, ends with gravity. So hopefully you said gravity. That is correct. So gravity can do work too. So two conditions must be met if something is doing work. 1, the object must move. 2, it must move in the same direction that the force is being applied. And then of course we can show the formula for work with this equation. Work equals force times distance. And then the units for work are going to be joules, and that is going to be the same unit that we refer to energy with. Okay, here are your practice problems. You're going to want to go ahead and pause. I want you to title this set of practice problems. Let me get the right drawing. Title them as work problems, so you'll use the work equation that I just showed you. Okay, and I'm going to go ahead and move on with the notes, but you pause this. Again, show your work, circle your answer. Okay, so moving on to power. Power is the rate at which work is done. And the formula for power, then, is work divided by time. So we can get a rate. And the unit for power is the watt, kind of like you think of with a speaker, or wattage for a light bulb. Now, how can you increase power? You can increase power by decreasing the amount of time that you do a given amount of work. And vice versa, if you wanted to decrease power, you would do less work in a given amount of time. So you got to remember that work has to stay constant. It has to be the same amount of work. You're just adjusting how much time it takes you to do it. So for example, if you're running 100 meters, well, not running, let's say pushing a box 100 meters. If it took you less time than the first time you did it, then you are using more power because you're doing the same amount of work in a less amount of time. If it took you longer to push a box 100 meters the second time you did it, then you would have decreased your power because it would have taken you longer. Alright, here are your power practice problems. And go ahead and label them power with a heading in your notes, just like I told you to do for work. And P equals work divided by time. Okay, and we will go over these in class, so go ahead and pause as needed to get these done. Show your work, circle your answer. And guess what? That's it for today. I will see you next time.